So we're going to talk about many things right now. We're going to start with the Jacobian. We're going to then do the moment inertia. Then we're going to talk about politics a little bit because I love politics, don't I? And the politic was a little iffy. I was just going to talk about how uh, there are liars among us. If they talk of, I just if there's a person that come from distant land and said that their people think that um, America's, friendly, or they thought that China is friendly, then whatever is false. That's the worst way to explain it, but I don't know. I should explain it better. Whatever. First of all, the Jacobian matrix. Not fun at all. Complete torture. But you can see what a Jacobian matrix is. It's basically trying to get volume because I should probably explain more. dv integral equals volume. And I just realized now that I should probably explain that in my other sections. Ah, shit, I didn't explain it correctly to the other sections. Um, yeah, that's fun. But moment inertia needs that. Uh, and moment inertia is defined by the integral of dm by r squared. Sometimes it's r squared integral of dm due to, if you look at the point masses, the moment inertia is for rotating object is the summation of m r squared. If you don't know, the precursor to integral is making a small summation, infinitely limited summation. So imagine that with a uniform density object. That is why we have r squared m, integral of dm. Which is why if you know dm is actually defined by the density times dv, or volume usually. Sometimes it is different where the density is also changing. Then you need to do a lot of integrals, and I don't want to do that here, so shut up. I don't want to do that integral right now. That would suck. That would be horrible because this moment inertia also sucked, and it's for uniform thing. And now I understand why all my calculus teachers don't want to actually professors don't want to show the integration of this because they suck. They suck ass. They're the worst things I ever done. Oh, okay, that's how I mean my system. Yes, this is the worst thing I have ever done in my life, doing a Jacobian and trying to solve this motherfucking thing that makes no sense. Unless you do vector calculus with all the dv's and how volumes is actually defined by three integrals. Yes, three integrals defines a volume, and um, you can get the volume with one integral by expanding it to another, but usually it's defined by three integrals. That's the easiest and most defined way to solve an integral problem. Did I make any sense? Oh well, that's how I'm going to explain it. A two integral can get the area usually, but it can also get the get a volume too. Not to say it's a good idea to use two integrals to get a volume, um, but yeah, I can show you kind of what it means. If you get the integral of a space like this, you're so you see this cube. That is what the region where if you do integral by three sides means. It gets the area of a funky area here, and it can get that area. An integral of two sets can get the region under the curve. Okay, but it cannot formulate it. If you can't get something like this, you can't get the area of something like this. But three integrals can. They're curved, so you can't get all three of it. But an integral of three can and will do that. An integral of one usually gets the area under, and if you do it right, you can get some kind of cylindrical void over here. You can do that, but two integrals can do it better because it can get a region over here and get a funky shape and a non-uniform format easily there. That's the power of three integrals. And if you're asking, does it plot like a fourth-dimensional nonsense shit? Maybe it does. I have no idea. But this question has been pissing me off because it took forever to actually solve this shit. This is the worst one. I'm not even sure I got this correct. I emailed the professor to see if I got this correct at all, but I get the right answer. All of these, I get the right answer. So I'm assuming I got it correct. I have one more I'm going to add here, which is the line with the maybe a few more actually. I want to prove all of them actually, but I did do the line one long time ago, and I have it somewhere in my notes. So I just have to grab it and then just paste it into this document. Which would be less amusing if the Jacobian wasn't a pure torture fest. A Jacobian, I didn't even know you needed it because I never used it in my physics class until today, when I was actually trying to prove all this shit. I wish the physics professor would have told me this, but the Jacobian is done by changing the y, x, and z coordinates into a format that makes sense. If you get let's just say, I don't know, I forgot what the, so this is, I believe, r, or this and this is theta, and then this is angle, and you put that down over here and do all that shit to get sine of this thing defines makes a shift. You can shift, you can do an integral that was originally from a coordinate plane into uh integral polar format by doing this. It's awesome. Actually, this is how you solve something like x to the square. This is impossible integral, and it's in physics. Isn't no in calculus is impossible. Right? That is also possible. But if you do a coordinate shift, you realize this is r, and this is just a number, so you keep it. Oh well, because of the Jacobian, if you change the polar, you need this. Oh, because it's 2r, you need to do dr d theta here. You need to do that because that is how it was defined. Actually, now I need to find what, if this is 0 to 1. This would be, what would it be? What would oh, that's why I couldn't get it. I needed two integrals here, 0 to 1. So actually, it would be a shape like this, 0 to 1, 1. Did I just make a torture question by accident? Oh, fuck, this torture question is awful. So, yeah, I did actually create something like this. And then you need to get the shape into polar form, so it's going to be 0 to 0. I hate myself. Why did I make this question? But it is, oh yeah, right. It's because statistics has the stupid darn questions all over the freaking board because this is a Gauss's law, and you can actually try to figure it out. Oh, it's actually r square over here. Sorry. So I think if I remember correct, the angle over here is 90, right? So it is 0 to, what was it again? Pi. What is this? Pi over 2. So it's 0 to pi over 2. The 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 angle comes from 0 to, well, here. So what would you do? Um, you would need to do 1 1 plug-in, so probably E, I'm guessing, because that's the longest one, and then you would do ER square R. I need to review my freaking calculus, vector calculus. I did not realize that's how you solve most of these shenanigans. These horrible problems with moment inertia, I can understand why no professor actually wants to cover it, because the proof is insane. It's fucked up. It's like a fuck up problem. Like, you give it to a student and they'll cry literally on the test unless they have done it before, which I'm so glad I did it now, because if the professor gives this question to me, which is not possible because I already passed that class of 2A and 4A. So if they did, I would been okay because I now know how to do this shenanigans, and I don't want to ever do this again. And I hope no professor give this question unless they have taught it properly. Fuck me.